Here we have a container that's in the shape of a cylinder like this, and this is the height of the cylinder, and this is the radius of the cylinder. And so we're given that the surface area, that's the area around the cylinder, and then plus the top and the bottom. And so it's a total surface area of 100 square inches. And what we like to know is what should the height and the radius be so that we get a maximum volume. And so as we can see here, as we change the height, let's say we make the height longer, and then the cylinder here will be longer, but the radius will be shorter because we restrict it by a surface area of 100 square inches. And so therefore we like to know what combination of H and R will give us the maximum volume of the cylinder. And so first we need to get the surface area formula. And so it's going to be the base right here. It's going to be the top plus the bottom and plus the lateral area. And so that's the area around the cylinder. That's the lateral area. And the top here is just a circle. And so the area of the circle is just pi r squared. Pi times the radius squared. And then plus the base or the bottom here, it's the same thing. So it would be pi r squared. And then for the cylinder, the lateral area or the area around the cylinder, then it's just the circumference of the base and then multiplied by the height. And circumference of a circle is 2 pi r. So we have 2 times pi times the radius and times the height. And then altogether, this will be 2. This is pi r squared plus pi r squared, so it's 2 pi r squared, and then plus 2 pi r h. And we're given that the surface area is 100, so we have S equal to 100. So this is equal to 100. So we end up with this equation right here. And since we want maximum volume, then what we can do is go ahead and solve for H right here. So that H would be a function of R. So this will be, so now we subtract 2 pi r squared from both sides, and we get this is equal to 100 minus this. And then divide both sides by 2 pi r. And so the height is equal to 100 minus 2 pi r squared divided by 2 pi r. And then we want the maximum volume. Is the volume of cylinder the formula for the volume of the cylinder is just the area of the base times the height. So the base is a circle, so it'll be pi r squared, and then times the height. So the volume is equal the height in terms of radius is this. And so now we end up with this, so let's simplify this. So this would be, so let's see, there's a couple ways to do this. Let's go ahead and rewrite this. This is the same as pi r times r, so that way we can, and then times this. So we can see that the pi r and the pi r here, they're canceled out. And so the bottom, we could have gotten rid of the 2 earlier. So now that's out. And then we could have gotten rid of this 2 earlier over here. 100 divided by 2, which is 50. And then 2 pi r squared divided by 2, which is pi r squared. And so now we end up with 50r minus pi r to the third. So r times 50 is 50r, and then r times pi r squared is pi r to the third. And so that's the volume in terms of the, is the function of the radius. And again, we want the maximum volume, and therefore we will do derivative of v with respect to r. So define maximum volume we need to do the derivative of dv, derivative v with respect to r, since v is a function of r. Derivative of 50r, it's just 50, and then minus pi, and then the derivative of r to the third is 3r squared. And so this becomes 50 minus 3 pi r squared. And then now we need to set the derivative equal to 0 and solve for r. And then right here, subtract 50 from both sides. And then divide both sides by negative 3 pi. And negative divided by negative is positive. And then take the square root of both sides. And this comes out to be about 2.30329. So that's the radius. And then now we need to get the height. And so the height is going to be this number squared, and then that number squared. And then simplify this on a scientific calculator, then we'll get about 4.6065. And summary for maximum volume, So given surface area of 100 for maximum volume, radius should be this, and then the height should be this. So given that the surface area is 100 square inches, then the height should be about 4.6 inches and the radius should be about 2.3 inches.